In this video, we will discuss Module 3A, and these are the topics. First, we will define position. Next, we will differentiate distance from displacement. Then we will solve problems involving speed, velocity, and acceleration. Let us start by defining mechanics. Mechanics is defined to be the study of motion, and we will discuss two of its branches. So first is kinematics, which is defined to be as the description of motion through mathematical equation. Then you have here dynamics, which is the study of motion and its causes. Under kinematics, we will discuss speed, velocity, acceleration, uniformly accelerated motion, free fall, and projectile motion. Under dynamics, we will discuss forces and the three laws of motion. Let us now discuss position. The definition of position is already on your module, and I believe that is self-explanatory. Therefore, let us move on to discussing the differences of distance and displacement. Distance involves magnitude. Displacement involves magnitude and direction. With that, distance is considered to be a scalar quantity, and displacement is considered to be a vector quantity. To further understand the differences of distance and displacement, let us have an example. We have here point A and then point B. If an object moves from point A to point B, the space that will be taken is called as distance. On the other hand, displacement is the shortest distance. On the other hand, displacement is the shortest length traveled from an initial point going to a final point. So the shortest length between A and B is called as the displacement. This is an indication that the object has moved or has been displaced. Another example. Let us have a rectangular field. Point A, B, C, D. An object from point A moves, going to point B, going to point C, going to point D, and returning to point A. If we're going to talk about distance, then we can say that the total distance in this scenario is from point A, going to point B, to point C, to point D, returning to point A. However, if we are talking about displacement, that is not the case. Remember that displacement is the shortest length from an initial point going to a final point. In this scenario, the initial point is A. The object moves from going to point B to point C to point D, but then again, it returns to point A. So is there a displacement? Or is there a space displaced? And take note, this is the initial point, and at the same time, this is the final point. Therefore, displacement is 0. We will now discuss speed, velocity, and acceleration. These different quantities are denoted by letters. So the letter that we will use for speed is v, and for velocity it is also v. For acceleration, that would be a. Speed is defined as the ratio of the distance all over the time elapsed. So that is also same with velocity. However, it would be displacement all over time. So as you can see, distance and displacement is denoted only by a single letter. So this is a scalar quantity. Meanwhile, velocity is a vector quantity. So this is magnitude with direction. For acceleration, this is defined as a description on how fast or how slow the change in velocity. So this will be change in velocity all over change in time. If you're going to expand this one, that would be v subscript f minus v subscript I all over t subscript f minus t subscript I. So the use of f subscript denotes that these are the values at the final point of the problem. Meanwhile, the subscript I denotes that these are the quantities at the initial point of the problem. Moving on to sample problem under speed. In 1980s, one of Asia's fastest running women was a Filipino athlete named Lydia De Vega. In the 100-meter dash event in 1986 in Seoul, South Korea, she was clocked at 11.53 seconds. Find her average speed. In solving physics problem, we can always use an illustration to better comprehend it. So in this problem, we know that this is a race, so there is the starting point and then the end point. This event is a 100-meter dash, and Lydia is able to run the 100-meter dash for 11.53 seconds. So the given in this problem are the distance, which is 100 meters, the time, which is 11.53 seconds, and we are looking for the average speed. Now for the formula, that would be v is equal to d all over time. Since we know the value of these quantities, we can just substitute. So that is 100 meters all over 11.53 seconds. So dividing that one, this will give us a quotient of 8.67 meters per second. We are now solving sample problem under acceleration. As in the previous example, imagine that Lydia De Vega attained a speed of 6 meters per second after 2 seconds from the start of the race. Solve the following problems using the given information. A. What is her average acceleration during this time interval? B. Suppose she attained a speed of 10 meters per second after 8 seconds from the start of the race. What is her average acceleration during the 2 to 8 second time interval? And C. Suppose at 8 seconds from the start of the race, she slows down to a speed of 7 meters for 2 seconds. What is her average acceleration for this time interval? Let us now solve problem A of the problem. We know that the event started from rest, so any quantity at rest will be equivalent to 0. And then, under this problem, she gained a speed of 6 meters per second at the end of 2 seconds. So the given will be the change in velocity is 6 meters per second, and then the change in time is equal to 2 seconds. In this problem, we are to solve for acceleration. So the formula of acceleration is the change in velocity all over the change in time. So substituting the given, that will be 6 meters per second all over 2 seconds. So doing the math, this will give you a quotient of 3 meters per second squared. So the acceleration of Lydia De Vega at the end of 2 seconds is 3 meters per second squared. Going now to letter B of the problem. For letter B, it will start from 2 seconds until the end of 8 seconds. So this is the time interval of 2 seconds to 8 seconds. At 2 seconds, we know that the speed of Lydia is 6 meters per second. Then her speed at the end of 8 seconds is 10 meters per second. So the given are the following. However, take note that at this point, which is the start of the problem, this will be the initial point. And then this will be the final point. Okay? So the initial velocity now is 6 meters per second. Then the initial time is 2 seconds. The final velocity is 10 meters per second. Then the final time is 8 seconds. Again, we are tasked to solve for the acceleration. So acceleration is the change in velocity all over the change in time. So substituting the given, that will be 10 meters per second minus 6 meters per second all over 8 seconds minus 2 seconds. So doing the math, this will give you 4 meters per second all over 6 seconds. So dividing that one, this will give us a value of acceleration, which is 0.67 meters per second squared. So at the end of this time interval, Lydia de Vega has attained a velocity. So at 2 to 8 seconds time interval, Lydia de Vega is able to attain an acceleration of 0.67 meters per second squared. Before we solve for problem C of the problem, let us refresh our mind. For letter A, we are tasked to solve for the acceleration at the end of 2 seconds. Then for letter B, we are tasked to solve for the acceleration during the 2 to 8 seconds time interval. At the end of 8 seconds, we know that the velocity or speed of Lydia is 10 meters per second. Then at letter C, Lydia decided to slow down for the 2 seconds time interval. So from the end of 8 seconds to this point, which she consumed 2 seconds, she slows down to a velocity or speed of 7 meters per second. So for letter C, we are tasked to solve for her acceleration during this time interval. So the given are the final velocity, which is 7 meters per second, then the initial velocity, which is 10 meters per second. Then we know that she slows down for a time interval of 2 seconds. So we are tasked to look for the acceleration. So the formula will be acceleration is the change in velocity all over the change in time. So this will give us 7 meters per second minus 10 meters per second all over 2 seconds. So 7 minus 10 will give us negative 3 meters per second all over 2 seconds. So the acceleration now of Lydia de Vega during this time interval is negative 1.5 meters per second squared. Why is it negative? Take note that in the problem, she decided to slow down. Therefore, the negative sign here connotes that she decelerated during that time interval.